Let's do another example. Okay, so in this example, in the first year of his business, Jack had takings of 228,000. Okay, so they're giving us the amount. So $228,000. They grew to, hold on, sorry. The takings are actually, this should be the principal. Okay, so that's the actual principal. And they grew to, so the amount should be 520,000 after 12 years, okay? Increasing at the same rate every year. And what annual percentage rate has his business been growing? So the question is asking us to find out his annual rate of growth, so it's per annum. Okay, and the other value they gave us is 12 years. Okay, so 12 years. So the number, so number of periods is equal to 12 years because it's compounded annually. Okay, what is the rate? Well, we can use the same formula again. So amount is equal to principal 1 plus r to the power of n. All right. Now we want to find the rate. Okay. Well, let's just plug the values in first. So 520,000 is equal to 228,000. 1 plus rate, we don't know what that is yet, to the power of 12. Okay, now let's work this out. So 520, so look here, so clear, 521, 2, 3, divided by 2, 2, 8, 1, 2, 3, gives us about 2.28. Okay, so we have 2.28 is equal to 1 plus r to the power of 12. Now, in order to get rid of this power of 12, we need to take the reciprocal function of that, which is actually the same as saying 2.28 to the power of 1 over 12, okay, is equal to 1 plus r to the power of 12 to the power of 1 over 12. Okay, and that means that this 12 and this 1 over 12, they cancel each other. Okay, so what you will get is 2.28 to the power of 1 over 12, which is equal to 1 plus r. Okay, this is a exponential law. It's part of one of the exponential laws. Okay, and now to get the rate, rate plus 1 is equal to this. So rate is equal to 2.28 to the power of 12 minus 1. Okay, so let's go back to our calculator again. Let's work that out. So 2.28 to the power of 12 minus 1. Oops, made a mistake. So 2.28 to the power of 12. All right. Now minus 1 from that. Sorry, let's try that one more time. Let's type that all up. Minus 1 is 19,733. Okay, so it is. Doesn't sound very right, does it? Sorry, I think I made a mistake with my calculation, so let's try again. So it's 2.28 to the power of 1 over 12. Now I need to put these in brackets. Now that would make more sense. Let's try that one. And minus 1. That's a lot better. So we have 0.07. Okay, so that's 0.07. So we get 0.071. Now we multiply this by 100 to get its percentage figure. So we get 7.1%. Easy. Let's move on. Finally, in this question, so we found the rate, we have found the principal. So what's left is to find the number of periods, or the number of years in this question. Okay, so how many years will it take a $452 stamp to be worth 1,000? Okay, so the principal is 452, and the final amount is 1,000. If it increases in value by 7.5% per annum, so the rate is 7.5% per annum. Assuming that the interest compounded annually, give your answer to the nearest whole number of years. Easy. Just use the compound interest formula. Okay, so the amount is 1,000. Okay, is equal to 452. 1 plus 7.5% per annum. We divide this by 100, so we get 0.075 to the power of n. Okay, so let's work out 1,000 divided by 452. Now, 1,000 divided by 452, 2.21, so 2.21 is equal to 1 plus, let's just say 1.075 to the power of n. Okay, I just cleared it to make some space, so it's 2.21 is equal to 1.075 to the power of n. Now, there is no really easy way to solve this. There is, but you might not have learned it yet. It's called logs and logarithms. But we'll use another method called guess and check. Okay? Called guess and check to solve this. And the way we're going to do that is we're going to introduce values for n. So we're going to start off with n is equal to 4 and see if we can find something which gives it close to 2.21 when we take 1.075 to the power of n. Okay, so let's try that. So 1.075, let's give it a try. Try n is equal to 4. So we have 1.075 to the power of 4. (1.075) to the power of 4. And we get 1.335. So we get 1.335. Okay, which is not equal to 2.21. So we need to choose a number which is a bit larger. Let's jump to something like perhaps 10. Okay, so we have 1.075 to the power of 10. Let's see what we get. 1.075 to the power of 10. Well, that's a lot closer. We have 2.06. That's very close. So we're almost there. 2.06. It's not exactly 2.21, is it? So let's try maybe one more. To the power of 11. So we have 1.075 to the power of 11, and lo and behold, we get 2.21, and we have reached our target. Okay, so therefore, n is equal to 11 years. All right, like I said before, there is an easy, well, not an easier way, there is a more complicated way, but you haven't learned that yet. It's called logarithms, and you'll be learning it when you reach year 11. But for now, just use the guess and check method to find out the number of years. So if you're asked to find the number of years in a compound interest equation, you need to use the guess and check method. Okay, so that's the 3 variations which you might be asked to solve in a compound interest question. Go ahead and try some answers now. Try some questions now. If you have any trouble, I'm always here to help, and I would love to help. All right, all the best. Talk to you later.